Okay, so 1/6 is the end of the road for this chapter, so it's a lot of absolute value stuff making a return. Some things that you've seen before, some things that haven't. Absolute value is sort of the star of the show. So the first thing worth a mention, it's not graphing heavy, but it's worth a mention. Does anybody remember when we graphed absolute values from our Algebra 2 quarantine life? What those look like they were V shapes. So we could split quadrant 1 in half, we could split quadrant 2 in half, make ourselves a V. That would be an absolute value graph. Again, the homework isn't graph heavy. Another way absolute value appeared in our Algebra 2 life is the fact that when this symbol gets used, there's a rule on that we've discussed this year again. If you get the radical sign used, do you remember what's the ruling about the answer?
Must be positive.
It's positive only. That's called the principal square root. So usually you'd expect that the square root of x squared should just take you back to basic x, but that's not quite true. It can't take you to a negative. And absolute value bars are handy in circumstances where negatives get outlawed. So Algebra 2, you might remember briefly, there was a lesson or two where we were putting bars around things sometimes just to guarantee positivity on rooted things. I'm sure you remember that the bars work like parentheses. You do what's in them first. So if your job is to do this problem, including the bars, what would your final answer be? It is 3. This problem we usually strike out on for a little while. Sometimes somebody has a suggestion, sometimes people don't. This has nothing to do with root 8. Okay, so you cannot subtract these in a traditional sense, like we subtracted those. Those are unlike radicals. But there is a simpler way to write that answer to this so that the answer is simpler than the problem. Does anybody have a suggestion? Strike out? No, Mark. We strike out some of yours completely on this question. My first hint would be, think about what your mind did when you did this one, probably, and how you came up with that answer. You kind of naturally did something here and made that happen. If you do the same thing here, you can get yourself an answer that's considered simple. And I'll just tell you. That's considered a simpler answer than the problem. Why is this considered simpler?
No absolute value.
There's no absolute value bars. Why don't we need the bars if I do what I did? What's the point of the bars?
To make it positive.
Yeah, guarantee us probably positivity, occasionally 0. You can do the absolute value of 0 and get 0, but 99.999% of the time, absolute values turn out positive. If I just flop the order, that guarantees us positivity. You don't need the bars. It's considered simpler because, I mean, honestly, what would you rather look at, this or that? That. I mean, that's just simpler looking. I think what your brain did here when you did this one is you thought 3 minus 6, no thanks, and 6 minus 3. That would be a negative, but I don't care. You know, make it positive. Your brain can do the same thing here. I want to go bigger minus littler, and then I don't need the bars. There's a little bit of that kind of stuff in the homework, doing some problems like that. Question about those. Then we'll dust off some Algebra 1 and Algebra 2 memories. If I give you an absolute value problem that's an equation, does anybody remember how you went about solving that?
You do like a duplicate with a negative.
Yeah, you do a double problem. One problem has what? What would one of the two problems be?
Positive 11.
Yeah, positive 11. Do you tinker with that at all?
No.
So we get a 2x plus 9 copied to equal a normal 11. And then
Same thing with negative 11.
same thing, but with negative 11. And then you'd solve this and get 1.
No, no.
Solve this and get -10. And if you wanted to check them, as always, you could plug it in. 2 times 1 is 2 plus 9, that's an 11. 2 times -10 is -20, plus a 9 would be temporary -11. The bars make it 11. Those are both a winner. What would the answer be if that was a -11?
Impossible.
Impossible. You can't have the bars equal a negative. If the bars equal a negative, that would be impossible. Question about that scheme? If I don't do an equal problem, but I do a less than problem, we take a different approach. Does anybody remember how we would take an approach on the less than stuff? Less than sandwich, which I think I invented that slogan. I've not seen that in a book. So less than's, we'd go less than sandwich. Who's in the middle of your sandwich? X minus 5, exactly as it is. High end, low end. And then when you want to get the X alone, we're doing the opposite, but in a more advanced way than whatever you do to one side, you do to the other. There's 3 sides. So whatever you do to the middle, you have to do to everything. All 3 of these locations get the same math happening. So high end, low end, voila. Those will appear in the homework. They also like to play with those on SATs. This will not appear in the homework, but also sometimes appears on SATs. So this is just thrown in as a bonus feature. This is not going to affect your homework life. Let me retread to this one for a second. What if the bars were less than a negative? Then what would the answer be?
Good question. Can't do it.
Can't do it. So we go with impossible on that. How about if the bars were greater than a negative?
Special R.
Yeah. Which means
Hey,
any numbers, all real numbers would work. It's an unlimited amount of solutions. Literally anything you put in for X would make that true if the bars were bigger than a negative. That's not what I'm doing. Do you remember how to manipulate the dual questionness of the greater than? Watch a 3x plus 2 twice. Let's think of a simpler problem then. What if this is just an x in bars, more than 7? Where on the number line can you find things that work for that? Where are there numbers with absolute values more than 7?
anywhere to the right of 7.
Anything to the right of 7, but also
Anything to the left of -7.
anything to the left of -7. We used to, on occasion, have some number line graphs that did that to us. That's kind of like what we're after. There was a magic word that went with that. Or. So on one side, we could be more than the regular 7. But on the other side, we could also be less than the negative version of the 7. This was actually an and story, but you didn't have to write the word and if you understood the less than sandwich. But we could have done this by going x minus 5 as is less than 9, less than 9. Throw the word and go same thing, but go greater than the -9, but do the word and in there and follow the scheme. You'd get to the same spot, but the ands we always did with less than sandwiches. This, if we got that x alone, x would be greater than
Five over 3.
5/3. This x would be less than
-3.
-3. We're good on that. Again, that doesn't appear, this problem type not appearing in the homework, but it doesn't hurt to hit a review. Not appearing on the board, but I think appearing in the homework, there are algebra moments where these need to become those, or vice versa. Do you remember under what circumstances we get some sign turnage?
When the number with X is in it?
Correct. If the number with the x, if it's multiplying or if it's dividing, and you're doing multiplying or dividing with negatives, the sign will turn. Never appearing in our life before, but appearing in the homework tonight. Another thing that makes you turn the sign is if you do reciprocals, which makes sense if you think about it, like 2 is less than 3. But if we flip these, a half of a cake compared to a third of a cake, you'd rather get half a cake, that's one cake, right? So reciprocals also make the signs turn, but we've never had that discussion until this moment. So if you're thinking your memory's failing you, it's not. That never came up until now. Question about any of that? Then here's a new thing, okay? We have had a fair amount of experience together, Algebra 1, Algebra 2, turning the less than absolute value problems into less than sandwiches. What we've never done is reverse engineered a less than sandwich back into an absolute value problem, and that is going to appear in the homework. So the formula that's going to govern that for you is, the way it's always going to look is x minus something I'm going to call xo, that's the midpoint of that piece of number line. That's always going to go in the bars and be less than, I'm going to just put a D now. The D would be the distance to an end, either the high end or low end from the midpoint. So if we look back at this one, between -4 and 14, who's exactly halfway between -4 and +14? Where's the middle of that zone? 5. And that's why this had a 5. How could you do math on these to figure out what the middle is between -4 and 14, other than counting it and meeting in the middle, which is kind of a drag?
Just do the average.
Just do the average. So we add those up to 10, we divide by 2, the midpoint would be the 5. And then from 5 to the high end of 14 is a distance of 9. Or from 5 to the low end of -4 is a distance of 9. That's what the 9 has to do. So here's a new question. So if we're trying to create something that looks like this, you first have to figure out what's in the middle here. From -5 to +7, the middle point. Would be 1.
Okay.
And it's set up to go x minus 1. And then the next question is, what's the distance from that 1 we just discovered to either of the ends? From 1 to the high end matches from 1 to the low end. It's both in either direction. 6. If you wanted to check that, you could do the process we did over there. Like, you could use one system to check the other one if you want to. There should be a consistency to that as you work it inside out. Question about that?
So you do the average to find the midpoint. Okay.
Yeah. You okay? And the last thing that you've never had before, which isn't really hard, there'll be a formula that governs this like too. There's a thing called target value. So the idea is they're going to give you a function, an equation, a formula of some sort, y equals whatever it may be. I'll just say f of x for now, so it could be just literally anything. We're used to the way these things work. You plug in some x's, some y's shoot out. Depending on what x's you put in, you can get different y's out of these formulas. That's just how the functions run. They're going to give you a target y, I'm going to call it yo, that you're shooting for, something you want to get close to. They're going to give you an allowable error that they're going to call p. It's like how much you could miss it by. and they're gonna have a story or a sentence or an instruction in some way that they're gonna want the y, which is changeable, to be within a couple numbers worth of that error compared to what it's actually shooting for. You know, sports analogy maybe. You know, you're on a basketball team, you're gonna play 20 games. You probably don't expect to win all 20. You probably don't expect to lose all 20. You might expect that a good season would be winning like 14, give or take 2 games. You know, you're thinking, I'd be happy with 14. I might win 16. I might win 12. You know, that's the range that I'm happy with. Your target there would be the 14. The allowable error would be the 2. Like, I might go 2 over, I might go 2 under, you know, I'd be happy with that either way. You know, we're trying to get our mystery number to be within a certain amount of something. Grades are like that for some people. You know, there's people that are like, you know, I'm thinking I should probably get about an 85. I'd be thrilled with a 90, but I know I won't beat it. I'd be happy with an 80. I hope I don't get under it. I'd be grounded. You know, their target there is an 85. Their allowable error they gave themselves was a 5. You know, and they're playing a game. You know, how much homework do I need to do to like stay in that happy spot kind of thing. That's the feeling of this. What you put in affects what you get out. There's a lot of circumstances in life where you have a target, you have a reasonable amount you might be willing to miss it by on the high or low end, and that's what this is doing. Question about concept. So here's the formula that governs this. It's always going to be, the y is going to be some kind of a formula that you're given. Like this y equals f of x function, formula, equation, whatever it may be. The yo is the target that you're shooting for. Your 14 wins or your 85% or whatever that target is. Throw that in bars, do a subtraction, and then there's going to be some sort of an error that you're allowing yourself a margin for error. You know, your 2 wins or your 5 percentage points or whatever I was saying in those stories. So they'll give you information. They'll say, hey, y equals this thing. We want to get within 2 units of a 7. So we're hoping to get 7 out of this. We'd be happy with 8. We'd be happy with 9. We don't want 10. It's too much. 6 is cool. 5 is cool. We don't want to be under 5. We have to stay within 2 of our goal of 7. So copy the formula, the 2x minus 1. Subtract what the target was, which was the 7. Bar that up. A less than. And then what was the error you were allowed? 2. And then we'll have to read the directions in the homework for different sections. They're not going to be happy with that. They're at the very minimum going to want you to clean this up. It's likely that they're going to want you to do the skills from 2 columns ago. Absolute value less than's, where can we head with that? Less than sandwich, so 2x minus 8, less than sandwich. Negative 2 versus 2. Add that 8 to get 10 versus 6. And then to complete the process, 3. So if you can keep your x's between 3 and 5 as they go in, you would keep the y's in the range that you wanted them to go as they come out. Also possible, depending on the directions of the section, they might want you to leave the bars alone and just have an x in there, but not a 2x. So if you want to get from a 2x to an x, you just have to divide by 2. But if you're going to divide the one thing by 2, you have to divide all by 2. So maybe something like that is an acceptable answer. It depends on what the directions say. But that's how those are going to go. We have a homework where we skip 3s. So I usually do 2 more of those because that is like totally new to our life. So I'll be back in a second with my book 30 there. So we're on 50. something 55. Let's take a little homework walkthrough if you want to join me on 55. So the first two, 1 and 2, are like where we came in with those absolute value problems. The one with the root 11 and then the other one that had the 3 that we started with. It's just those basic problems. 3 to 8 is absolute value equations. So we did one of those at the top there of the second column. 9 we skipped because that's a 3. 10 they're asking you whether things are true or false. So you're just trying to read through and think with them if you can and look for pattern. You know, if something is less and they change one side, they should change the other side. Like if they're adding 2 here and they add 2 there, you're just making sure that they stayed within algebra bounds and did legal things on 10. And you're going to either say that what they did is fine or what they did is breaking rules. 11 to 16 is matching. So you're just dealing with those less than sandwiches, and then we're skipping some of them. So it's not true matching. It's a little bit of funny matching where you don't use every choice because we skipped around. But every answer on 11 to 16 should be able to be found on the A, B, C, D, E, F, G zone. 17 to 24, we're still doing less than sandwiches. 25 to 28, we're doing the reverse less than sandwich, the thing with the midpoint and the distance to the end and the formula we did here in column 3. And then starting on 29 is where the target values kick in. So for 30 is a pretty straightforward one, I think. What would the bars start off with on 30?
X squared minus 5.
X squared minus 5. So we're just going to copy that formula that they're giving us.
Minus
Then minus which thing?
11.
The 11. Wrap that up in bars. Less than 1. And then we'll just try to clean up. X squared
Minus 16.
minus 16. Then
Do we want a factor or no?
no,
Less than 6.
less than sandwich. High end,
1.
low end,
Negative
middle zone.
1. X squared minus 16.
Then
Add 16 of those.
that's 16s. High end,
17.
low end.
15.
Finally,
X. 3 to 17.
root of 17.
Root of 15.
Yep. What if you had a root of 18?
Do 3 root 2.
Do something to like 3 root 2. You good on that?
Yeah.
Like,
Yeah.
question on 30. 35 to 42, they switched the directions. Instead of wanting it to look like this is the group where they want it to look like that. They want to go, leave the bars, leave the X. You know, they get that from the last sentence. It says, describe it as an interval with an inequality of this form, bars, less than, stuff. So let's do 36 just to do it. So how would 36 start? Yeah, bars, 2x minus 1, yep. After the 2x minus 1, close. Plus 5, because it's minus a negative, so the old minus makes plus. Less than, grab the 1. That other number doesn't matter, just ignore that. So 2x plus 4 is less than 1. And then for the answer to be the way they want it to look, we want an x there, so plus 2, less than a half. And then we're good. And conspicuously, the -2 that we ignored, that's +2 caused that -2 to happen. But you had to run through the steps to figure out the half anyway, so there's nothing really to be gained by that, but there's sort of like a hint to the answer contained in the problem with that extra little factor. That's our thing, so we skipped the 3s, going as high as, I think it was 38, if I'm remembering.
For the first problem in that kind, where it was like 3 less than x less than 5, is that x what you would plug in for the form?
Yeah, so if you put in any x that's between 3 and 5 into this, it'll cause the result to be 7, give or take 2. In other words, the y's will be somewhere between 5 and 9, as long as the x's stay between 3 and 5.
Because I was thinking you just plugged it in for 5, but now I get you plugged it in for that thing. Different.
These are the x's would go in, and it would cause those results for the y's. There's things that use that. I don't have any experience in life with that, but there's just certain situations in life where you do have a certain range that's desirable. The too high is bad and too low is bad, and you're trying to find that sweet spot.